3I Atlas is gaining speed as new images reveal unusual changes in its tail structure. In this video, we unpack the data, the comet physics, the anomalies, and whether this interstellar object poses any risk to Earth. Something entered our solar system in 2025, moving faster than anything we have ever seen, shedding material in ways no comet should, and leaving behind a trail that confuses scientists around the world. Its name is 3I Atlas, the third interstellar object ever discovered, but the first to behave like this. Astronomers spotted it in July using the Atlas telescope system, a network of sky survey instruments in Hawaii, South Africa and Chile. What they found wasn't just a visitor from another star system. It was a massive, fast-moving object nearly the size of central London, travelling at over 200,000 kilometres per hour, on a hyperbolic trajectory that guarantees it is not bound to the Sun. Most scientists initially called it a comet. A big one, yes, but still a comet. Yet from the first observations, something didn't feel right. Its brightness suggested an enormous size, but its motion and mass loss didn't match any comet model we know. And as new data arrived, the anomalies only grew. Its tail didn't behave like a tail. Its chemistry didn't behave like comet chemistry. Its mass didn't behave like comet mass. And worst of all, its trajectory was unusually aligned with the orbital plane of the planets, something that statistically should almost never happen. Some scientists say these are just coincidences, rare but natural. Others, including Harvard astrophysicist Avi Loeb, argue that the object shows signs of something more, something engineered. In this documentary, we'll break down every anomaly, every data point, every debate, and every possibility. We'll examine the physics of mass loss, the strange nickel emissions, the unexpected brightening near the Sun, the anti-tail that points the wrong direction, and the new high-resolution images showing multiple narrow jets stretching nearly 1 million kilometres. Jets that may be natural or artificial. And finally, we'll explore what this object means for us, for science, for our understanding of interstellar visitors, and for the possibility, however small, that we're witnessing technology not made on Earth. When 3I Atlas was first spotted, astronomers quickly realised they were not looking at a typical icy rock drifting in from the Oort cloud. Its orbit was not elliptical but hyperbolic, meaning it came from interstellar space and would never return. Its speed, direction and early activity all pointed to something unusual. For most comets, we only see outgassing and tail structures once they get close to the Sun, when the heat begins to vaporize their ices. But 3I Atlas was shedding material even at extreme distances, more than 4 times farther from the Sun than Earth's orbit, where temperatures are far too low for significant sublimation. Despite losing an estimated 150 kilograms of material every second at that distance, its trajectory showed no measurable recoil, the kind that every comet experiences when jets of gas push against its surface. To resist recoil from that much mass loss, the object must be extraordinarily massive. Avi Loeb and 2 colleagues analysed more than 4,000 motion data points and concluded that 3I Atlas must weigh at least 33 billion tons. That's 1 million times heavier than the first interstellar visitor, Oumuamua. And this creates a deeper puzzle. If the galaxy is full of objects like this, why have we not seen countless smaller ones before? Why would the third interstellar object ever detected already be a giant city-sized body? Models of galactic debris suggest objects this large should pass near the Sun once every 10,000 years, not once a decade. Something about 3I Atlas does not fit expected population statistics. Combined with its early activity, its brightness curve, and its stable trajectory despite intense mass loss, the first anomaly emerged, the mass budget problem. There simply isn't enough known material in interstellar space to regularly deliver objects this big at the rate our telescopes are now detecting them. And if 3I Atlas is not natural in origin, the next questions become far more intriguing. The next anomaly appeared when astronomers calculated the angle at which 3I Atlas entered the solar system. Comets from deep space arrive from random angles, from above or below the plane of the planets, because our solar system is just a thin disk in a much larger 3-dimensional galaxy. But 3I Atlas arrived almost perfectly aligned with the planetary plane, within just 5 degrees. Statistically, the odds of that happening by chance are roughly 1 in 500, It's not impossible, but it's unusual, and what makes it stranger is that 3I Atlas is only the third interstellar object we have ever detected. Why would the third one already line up so precisely with the geometry of our solar system? Avi Loeb suggests one possibility. Such alignment might be intentional. If an advanced civilization wanted to send probes for reconnaissance, they might aim them along the plane where most planets reside. But mainstream astronomers disagree. They argue that while rare, such alignments do happen. Even so, the alignment becomes harder to dismiss when combined with the other anomalies: mass budget problems, early outgassing, and later, the strange behaviour of the tail. For now, the trajectory alone is not proof of anything artificial, but it raises a flag, and in astronomy, multiple red flags appearing together often mean the underlying model is missing something important. 3I Atlas was not behaving like a typical comet, and its inbound path was the second clue that something about this visitor required deeper investigation. As telescopes began collecting spectroscopic data, another anomaly emerged: unusually strong emissions of nickel, specifically nickel with very little accompanying iron. In natural objects, nickel and iron are chemically linked. They tend to exist together in similar ratios across asteroids and comets. But 3I Atlas did not follow this pattern. It showed nickel emission without the expected iron signature. Pure nickel with low iron is not something observed in natural comets, but it does appear in engineered materials, specifically industrial nickel-based alloys used in aerospace engineering. Loeb noted that the only time we've seen nickel dominance like this is when humans manufacture strong, heat-resistant metals. Now, this does not prove 3I Atlas is artificial. Nature can be surprising, but the chemical signature was the first direct physical clue that something inside this object might not match typical comet composition. Combined with the mass estimates and the strange trajectory, the chemical anomaly added yet another layer to the growing list of mysteries. Mainstream scientists again argued that unusual chemistry does not imply artificial origin. Rare comets may contain exotic mixtures. But in the known catalogue of comets observed over decades, this nickel-dominated emission has no precedent. If 3I Atlas is natural, it is unlike any comet we have ever studied. If it is artificial, the choice of nickel would make sense. Nickel alloys resist heat, stress, and corrosion, all useful for long-distance interstellar travel. For now, the data remains ambiguous. But the nickel signature stands as one of the strongest hints that 3I Atlas might be more than a frozen rock drifting through the void. During July and August, astronomers observing 3I Atlas noticed something deeply unusual in its tail. Instead of pointing away from the Sun, a fundamental rule of comet physics, the object displayed a bright structure extending toward the Sun. This phenomenon, called an anti-tail, is extremely rare and happens only under specific geometric conditions. But even by anti-tail standards, 3I Atlas behaved strangely. The direction, brightness, and persistence of the structure did not match simple models of dust alignment. And then, as the object moved further inward, high-resolution images revealed long, narrow jets extending nearly 1 million kilometers in both directions, toward the Sun and away from it. No comet has ever exhibited such consistent collimated jets. Natural comet jets are messy, chaotic, diffuse. But 3I Atlas produced thin, straight streams of material that behaved more like propulsion exhaust trails than comet outgassing. Loeb calculated the total mass contained in these jets and estimated around 5 billion tons of material, an enormous outflow inconsistent with earlier size constraints from Hubble. To produce that much mass loss through natural sublimation, the comet would need to be at least 23 kilometers wide, far larger than any previous measurements allowed. The only natural explanation would be a catastrophic breakup into many pieces, exposing new surface area and accelerating sublimation. But no such fragmentation has been observed. The alternative is that the jets are not sublimation at all, but something else, something controlled. For Loeb, the presence of 7 highly collimated jets, extending vast distances, raises the possibility of technological thrusters. If the jets move faster than the speed expected from sublimated gases, around 400 meters per second for CO2, then the case for propulsion becomes stronger. If they exceed 1 or 2 kilometers per second, natural explanations vanish entirely. Future spectroscopic measurements may determine their velocity. But for now, the jet structure stands as one of the most striking anomalies seen in any interstellar object. On October 29th, 3I Atlas reached perihelion, its closest approach to the Sun. What happened next shocked astronomers. The object brightened by a factor of 5, far beyond predictions. Comets brighten near the Sun, yes, but not like this, and not with this timing. More importantly, its trajectory shifted noticeably afterward, as if something had applied a force to it. Loeb calculated that to cause such a deviation, 3I Atlas would have had to lose around 15% of its entire mass in a short burst. That would imply catastrophic fragmentation or explosive sublimation, yet telescopes did not detect a cloud of debris consistent with such a violent event. Instead, what telescopes did see were the long jets continuing in multiple directions, behaving inconsistently with natural comet outgassing. The brightening event combined with the trajectory shift suggests a sudden release of energy. This could be natural, internal pockets of gas bursting into space, or artificial thrusters firing during a maneuver. The Sun passage marks a turning point in the 3I Atlas investigation, because it represents the moment the object diverged most dramatically from predictions. Mainstream astronomers insist this is just unusual comet behaviour, nothing more. But Loeb argues that the magnitude of the event, the lack of debris, the trajectory shift and the jet structure all point to something else. As of now, the data remains inconclusive, but the perihelion brightening is one of the most dramatic anomalies in the entire 3I Atlas story. If the jets coming off 3I Atlas are technological, they would differ from natural comet jets in several key ways. First, their exhaust velocity would be far higher. Natural sublimation produces gas speeds around 400 meters per second. Chemical rockets exceed 2,000 meters per second. Ion thrusters exceed 30,000 meters per second. Alien technology, if such a thing exists, could achieve even more. Second, technological jets would be collimated, meaning tightly focused. Natural comet jets are diffuse. 3I Atlas's jets appear narrow and straight across enormous distances. Third, controlled propulsion would produce precisely the kind of trajectory shift observed after perihelion, small intentional course corrections. If the jets are propulsion, 3I Atlas might be a probe, or a fragment of a much larger structure, or even a derelict craft drifting through interstellar space. Loeb refuses to guess. He says the best approach is to observe without preconceptions, to treat the object like a blind date of interstellar proportions. And he emphasizes that if the jets turn out to be technological, their exhaust speed will give it away immediately. Velocity is the key. If spectroscopy reveals speeds impossible for natural gases, the debate will end in a single measurement. But if the jets are slow, natural explanations return to the forefront. The next few months of observations are critical. For now, the possibility remains open, not proven, not disproven, simply waiting for more data. As the 3I Atlas data has accumulated, a public debate has formed around Avi Loeb and his interpretation of the anomalies. Popular scientists like Neil deGrasse Tyson and Brian Cox have criticized Loeb, arguing that he is reading too much into limited data. Brian Cox even stated that Loeb was talking drivel regarding technological hypotheses. But Loeb counters that many critics are not involved in the scientific analysis itself. They comment from the sidelines. Loeb has written 12 scientific papers on 3I Atlas and works directly with the observational data. He argues that the foundation of science is not certainty, but curiosity. He says that refusing to consider unusual explanations simply because they seem unlikely is the opposite of scientific humility. Loeb points out that most critics do not study interstellar objects directly. They communicate science but do not produce research. He describes himself as a scientist in the trenches, gathering data rather than performing for public audiences. For Loeb, the debate is not about aliens, it is about evidence. If the data points to natural behaviour, he will accept that. But if the data points elsewhere, he argues that scientists must remain open to possibilities, no matter how uncomfortable. His disagreement with popular figures highlights a deeper divide between communicators and researchers, and between consensus and curiosity. Loeb often emphasizes that human technology is extremely young. Our modern scientific era spans barely a century. Yet the galaxy is billions of years old. Most stars formed long before the Sun. A civilization with even a million-year head start would have technological capabilities far beyond ours. He often references Arthur C. Clarke's novel Rendezvous with Rama, which imagines a cylindrical spacecraft tens of kilometers long passing through the solar system. For Loeb, the size of 3I Atlas does not rule out technology. It may indicate technology far beyond human scale. He also points out that humanity has already launched 5 spacecraft that will leave the solar system: Voyager 1 and 2, Pioneer 10 and 11, and New Horizons. If we can already send probes into interstellar space, why assume others cannot? He argues that the possibility of alien probes is natural, not extraordinary. Meanwhile, Loeb suggests that discovering technological objects in space would radically shift humanity's worldview, impacting religion, science, philosophy, and geopolitics. It could inspire unity or fear. It could redirect global priorities towards space defense or exploration. And it could finally answer the question of whether intelligent life exists beyond Earth. For Loeb, the stakes are high, not because aliens are likely, but because they are possible. And possibility alone demands attention. Beyond 3I Atlas, Loeb's worldview expands into broader questions. Where did life originate? Could intelligent species have existed long before us? Why do we assume humanity is unique? He notes that Mars cooled before Earth, and may have developed life earlier. Meteorites from Mars have reached Earth without being heated above 40 degrees Celsius, meaning microbes could have survived the journey. In that scenario, we might all be Martians, life transported between planets by natural processes. Loeb also suggests that past civilizations on Earth could have existed hundreds of millions of years ago, with their traces erased by geological activity. Most of Earth's history is unrecorded. Human civilization is only 8,000 years old, a blink in geological time. If advanced species rose and fell long before humans, we would not know. This perspective shapes Loeb's view of 3I Atlas. He does not assume humanity is first or alone. He sees the universe as vast, old, and full of possibility, and he argues that only open-minded science, not rigid consensus, can reveal the truth. Whether 3I Atlas is natural or artificial, he believes the discovery will teach us something profound. Either it expands our understanding of comets, or it expands our understanding of life. 3I Atlas will make its closest approach to Earth on December 19, 2025, just 6 days before Christmas. Thankfully, it poses no collision threat. Its path keeps it far from Earth. But this flyby offers a rare opportunity. If the object is natural, the flyby will allow detailed spectroscopy, imaging, and tail analysis. Scientists will be able to measure jet velocity, mass loss rates, composition, and structural changes with far greater precision. If it is artificial, the flyby may reveal clues, exhaust speeds, unusual materials, or even structural patterns inconsistent with natural ice and rock. Loeb says the next few months will provide a definitive answer. Either 3I Atlas will behave like a comet, shedding volatiles in predictable ways, or it will continue producing anomalies that resist natural explanation. In either case, the December flyby will be one of the most important astronomical events of the decade. It may settle the debate, or ignite an entirely new one. The story of 3I Atlas is not about proving aliens. It is about scientific curiosity. It's about allowing data, not assumptions, to lead us. It is about recognizing that the universe is older, stranger, and more complex than our models often admit. Whether 3I Atlas is a comet, a broken fragment of something ancient, or a technological relic drifting through the dark, its arrival forces us to confront our uncertainty. It challenges our confidence. It stretches our imagination. And it reminds us that interstellar visitors are no longer theoretical. They are real, they are detectable, and they are coming more frequently. With future surveys from the Vera Rubin Observatory, we may witness a new interstellar object every few months. Some will be ordinary, some will be strange, and one day, perhaps sooner than expected, one of them may not be a comet at all. The universe is watching. The question is, are we ready to watch back?